Next, we're going to look at section 25.4, hypothesis testing. This has been something that I've used over and over throughout my career, and I find it very useful. Often I've had to rehearse how I introduce my conclusions using a hypothesis test, but when you get it right, it can be a very convincing argument. And if you I learned that a hypothesis test can be very useful for winning arguments, and therefore I've employed them a number of times. What's the purpose of a hypothesis test? It's to assess the plausibility or credibility of a specific statement or hypothesis. Such a statement is called a null hypothesis. Each hypothesis test also requires an alternative hypothesis. That is, what we're always doing is saying, do I believe that these two things are more or less equal strength, or that this soil is above or not above a particular pollution threshold or allowed chemical concentration? That's the kind of hypothesis test that we'll be making. Whenever we have a specific statement we want to test the credibility of, we have to have its alternative. Do we believe the soil is contaminated, or do we have no reason to believe that it is contaminated? So we have our hypothesis, our null hypothesis that we want to test, and the alternative hypothesis if we can't prove or aren't convinced of the null hypothesis is true. After test, you'll either accept the null hypothesis or the alternative hypothesis. So it's either I'm right or I'm wrong kind of result, and that's very satisfying. Some basic definitions in a hypothesis test. First, we have the null hypothesis, often written as H0, and it's the assertion that you want to test. Now, mind you, you might be rooting for the alternative hypothesis, but we can only set certain kinds of statements up in a null hypothesis, and then we will, at the end of a result, be forced to take the alternative hypothesis. You may need to set up your hypothesis test where you know you're rooting for the alternative hypothesis, but sometimes you'll be rooting for the null hypothesis. And in court cases, you might be called as an expert witness for either side. So you'll need to know the different components and what these hypothesis tests mean. When we set up a hypothesis test, we can be right and we can prove that the null hypothesis is right and that it is right and we didn't make a mistake, or we can prove that the null hypothesis is um, right and it may in fact be right. However, it's possible that we could make a type 1 error, and that is when we're rejecting the null hypothesis when it's actually true, or we could make what's called a type 2 error, and that is accepting the null hypothesis when it's actually false. So we can be right by putting our money on H0 and it is true, or putting our money on HA and it is true, or we could be wrong through a type 1 error when we've rejected H0, but it's actually true. And the last possibility is we accept H0 when it's actually false and make a type 2 error. When we set up a hypothesis test, we need to create a level of significance, and we usually need to state this in advance of setting, or when we set up the test before we look at the results. And it represents our chance of making a type 1 error. If you set up a very low alpha so that you make a limit the chance of making a type 1 error to a very small probability or very small possibility, what you will have done is created a very large possibility that you'll make a type 2 error. So we usually look for a balanced level of significance where we're balancing out type 1 and type 2 error. The next thing that we get out in a hypothesis test is a test statistic, and that's calculated from the data set. Then we'll usually have a critical statistic value, and we'll use the level of significance to find that statistic value. After that, we compare our test statistic to the critical value. If we have an absolute value, a relatively small test statistic, that means we're going to have no reason to reject the null hypothesis, and it comes out the winner. If we get big test statistics in magnitude, so we take the absolute value compared to the critical value, then we're going to end up rejecting the null hypothesis in favor of an alternative hypothesis. So that's how a hypothesis test works, and you'll definitely want to look at some of the cases to see how these work in examples. One of the first cases that I wanted to look at, I wanted to include as part of the notes because I have a lot of the details worked out as I move through this step by step. So suppose we've been working with, or you work for, or doesn't matter, there's all sorts of parties involved here, but a brandy manufacturer asserts that his brandy contains 40% alcohol. A collection of 30 samples of the brandy were collected, and we find that they were more or less normally distributed when we looked at the percent alcohol in each of those 30 samples, and we had a sample mean of 38.805 and a sample standard deviation S equals 1.856%. We decide to use a 5% level of significance and want to decide, should we accept the manufacturer's claim that the brandy contains 40% alcohol? So thus we have the null hypothesis that the brandy manufacturer is right, that he's got at least 40% alcohol, against the alternative hypothesis that we don't believe that there is as much as 40% alcohol. We think it's less than that. So HA is that the mean of the alcohol content is less than 40%. We decided to use a 5% level of significance, which is a fairly common level of significance to use. It's a good balanced value. Then we calculate our test statistic using the sample mean minus the hypothesized mean, so 0.38805 minus 0.4 in the numerator, and then in the denominator we use S divided by the square root of n, where S was the sample standard deviation and n is the number of observation in our sample. And when we do this, we end up getting a t-value of minus 3.527. We compare this test statistic to the critical value of t. We get this from the t table. So we look up the critical value of t, or z, but in our case we're going to be using the t table. And here for the number of degrees of freedom is n minus 1, or number of observations minus 1. So we had 30 observations, so we have 29 degrees of freedom. We look up the critical value, and it's 1.7. Now we compare our test statistic to the critical value. If the absolute value of our test statistic is less than the critical value, then we accept the null hypothesis. If, however, we have a relatively large magnitude for our test statistic and it's greater than t-crit, then we reject the null hypothesis in favor of the alternative hypothesis. In this case, we're comparing the value, which was minus 3.9, to the critical value 1.7, and we have a relatively large test statistic, so we have to reject the null hypothesis in favor of the alternative hypothesis. So we don't believe the brandy manufacturer is right about the assertion that it's got at least 40% alcohol. And we have a fairly convincing data set to demonstrate that.